Good morning. Today we are going to continue with lesson 9 of module 7. This lesson is pretty similar to the lesson we did on Tuesday, informally fitting straight lines to data, that line of best fit that we call it. Today we are just going to do a little bit extra of a step and create an equation for that line of best fit and then use that equation to make predictions. All right, let's go ahead and get started. So starting with example 1, we are working with some data about crocodiles and alligators. It says scientists are interested in finding out how different species adapt to finding food sources. One group studied crocodiles, or crocodilians, to find out how their bite force was related to body mass and diet. The table below displays the information they collected on body mass and bite force. So just want to look at this table real quick to talk about what they have found. They have a bunch of different species of crocodilians. They have the body mass of each one and then the bite force. Okay, and then on the next page we're going to see this put into a scatter plot. So let's go ahead and move to the next slide. All right, so here we have that information that was in that table displayed in a scatter plot. It's much easier to see a trend, to read the data. It says, as you learned in the previous lesson, it's a good idea to begin by looking at what a scatter plot tells you about the data. The scatter plot below displays the data on body mass and bite force for the crocodilians in the study. Number 1, describe the relationship between body mass and bite force. So looking at this relationship, you can see that as body mass increases, bite force increases. So one thing I want to point out to you, that if X increases and Y increases, then our trend is positive. Okay, and also looking at this data, I can see that it does form pretty much a line. It is going upward in this linear pattern. So this is a positive linear relationship. Okay, please make sure you write that down. Number 2, it says draw a line to represent the trend in the data. Comment on what you considered in drawing your line. So I'm going to draw my line right here. And remember that our strategy is to be as close to as many points as possible. So I'm going to be starting probably at this 200 mark right here. And I'm just going to go straight through most of these points. I do see a couple of outliers, so I'm just going to try to not focus on those and mostly focus on these other points. So I'm trying to not focus on this one right here, and maybe not even that one right there. And I'm just going to draw this line and make my line a little bit bigger. Okay, there's my line of best fit. I got as close to as many points as I could, and I started at that number 200 in bite force. Okay, so what I considered here was getting as close to as many points as possible. That was my strategy. Please write that down. Getting as close to as many points as possible. I also made sure to recognize that there were outliers on this. Okay. Number 3, it says, based on your line, predict the bite force for a crocodilian that weighs 220 pounds. How does this prediction compare to the actual bite force of the 220-pound crocodilian in the data set? So 220 pounds is going to be right about here. So if I were to draw this line, match it up to where it hits my line of best fit, and bring it across, I would say that my prediction based on my line of best fit would be that this crocodile has a bite force of 800 pounds. Okay, so that's my prediction. However, what was the actual bite force of the crocodile in the data set that was 220 pounds? It's indicated right here. This is actually a crocodile that they surveyed that was 220 pounds. You can go back and look at that table if you need to see it. And this crocodile actually, I think it has a bite force of like a little less than 400. You can go back and check on the last page, but this is the actual answer. About 400 pound bite force. Now you'll notice that this was one of the outliers I did identify. So that's why it does not fit our line of best fit and our prediction does not match what actually happened, is because this was an outlier according to our data. And we even identified that before we made our line. Okay? We're now going to continue on. Just please make sure you have all of this down. All right. So on this page, we see the same situation, the same scatter plots, but we have very different lines of best fit. So it says several students decided to draw lines to represent the trend in the data. Consider the lines drawn by Sol, Patty, Marissa, and Taylor, which are shown below. For each student, indicate whether or not you think the line would be a good line to use to make predictions and explain your thinking. So I'm going to have you guys do this in breakout rooms together. And I want you to either tell me if it is a good line to use or not a good line. You can literally just put a check or an X underneath their name over to the right. And then I want a brief explanation as to why is it good, why is it not good. Okay? So you're going to take 5 minutes to do this in your breakout rooms, and then we'll come back together and check it. Let's go ahead and split up into our rooms. All right, we're going to go over this, and I'm going to let you know that our answers are probably very different because you have not been doing this for a very long time. And for a lot of these, you might just say, oh, that looks like a good line of best fit, but we want to get really specific as to what we could have done better with some of these. So looking at Sol's line right here, I would say that this is not a good line of best fit because it overestimates most of these predictions and underestimates most of these predictions as well. So there's a lot of points that are high up here that are off of the prediction, right? There's only one that's on it. And there's a lot of points beneath that are off if we were to use this line to predict as well. In fact, the only one that would hit the line and we would accurately predict would be this point right here. It is the only one that actually lands on the line. So that's going to be my answer is this is a no. And the reason being is that it tends to overestimate and underestimate the bite force. I'm just going to put BF for bite force. Okay. Moving on to Patty's line. Looking at Patty's line, I would say that this one is a very good line of best fit. We have a lot of points right here that are right on the line that would be predicted right here, right here. So we went through as many points as I think possible. And there are a few that are kind of farther away, but it's closer to a lot more points than that last graph, right? It's going to predict very accurately a lot of these points. And the ones that it doesn't accurately predict, it's really close to all those green dots up here, right? So I would say Patty's line is a yes. Because it's as close to as many points as possible. Okay. Moving on to Marissa's line. Marissa's line, I mean, you should have been able to tell really quickly this is a no. There are so many points below this line. It definitely overestimates the bite force of these crocodiles. Clearly overestimates. All right. And then the last one, same thing, but it now underestimates. There are so many dots way up here, and the line is too low. Okay? doesn't fit that trend. It's under it. All right, so those are the answers you should have down here. I'm going to give you a minute or so to make sure you have something similar to what I have. I know you probably wrote something different with your groups. And then we will move on. All right, continuing with the same situation, it says, as you learned in the previous lesson, it's a good idea to begin by looking at what a scatter plot tells you about the data. The scatter plot below displays the data on body mass and bite force for the crocodilians in the study. What is the equation of your line? So we want to draw another line here, and we want to make sure that it's something we can actually calculate pretty easily. So the things we want to look out for are our slope, and we want to look out for our y-intercept, because that's how we're going to write the equation of this line, right? We're going to find a slope for it, and we're going to find an initial value or a y-intercept for it. Okay, so I'm going to go ahead and zoom in on this graph. And the first thing I want to do is figure out where I want to start my line. In my opinion, it's always nice to start at an increment, like one of the tick marks that are on your line. So I want to start here on this 200, because then I know, oh, my B value, my initial value is 200. Okay, so that's the first thing I'm going to do, is I'm going to identify my B value. The second thing I want to do is I want to figure out maybe where is the end point going to be. Okay, well, if I were to draw a line through this, I would want it to hit as many points as possible. So I would want it to go through these, right? Maybe hit this one, try to hit that one, try to come close to this one, etc. So it's probably not going to hit one of these points that is already on this graph, but I can figure out where I want it to hit on my graph lines. So I'm going to redraw this line that I just kind of dotted and try to make it as close to as many points as possible. It's definitely not straight right now, but I'm trying to make it straight. Okay, and so I'm going to kind of go towards the end and figure out where does it hit right here for 400. Okay, I would say it hits at 1400. So I got 1 point right there. So this point is 400 on my x, 1400 on my y. And then I want to choose a second point, kind of towards the beginning maybe. I would say it's this one right here, 100, 400, 100, 400. And again, I'm looking for clear numbers because I'm going to calculate this right now. I'm going to do some math. And so now I need to find my m value. So remember, our equation for m, or slope, is y2 minus y1 over x2 minus x1. So I'm going to be doing y2, 400, minus y1, 1400, over x2, 100, minus x1, 400. All right. 400 take away 1400 is negative 1000. And 100 take away 400 is negative 300. The negatives cancel out, and I'm left with 1000 over 300. And then my zeros cancel out, and I'm left with 10 over 3. Okay, I can leave it as a fraction if I want, or I can turn it into a decimal. It is completely up to you, but I just found my m value. So now I have my b value and my m value. I can write my equation. Y equals 10 over 3x mx plus 200. Okay? And that's how you would write an equation for a line of best fit. You would find 2 points, find your m, and you would start at a value, and that would be your b value. Okay? We can then use this equation to make predictions later on that are really accurate. Instead of just drawing those lines, like the red lines on the graph, we can actually use the equation. Okay? Let's go ahead and move on. All right, so same situation again. Here we have this graph and it has 2 points pointed out to us. This one that's a dwarf crocodile right here, and this one that's an Indian, I can't say that word, croc that's right here. You'll notice that one of these is pretty close to the line and one of these is a lot further away. This one was one of our outliers. So we knew that that was going to be the case. Basically, our first question says, does her line predict, well, would Patty's line have resulted in a predicted bite force that was closer to the actual bite force for the dwarf crocodile or the Indian crocodile? So her prediction was closer for this one because it's closer to the line of best fit. So it's closer to the line of best fit, so that's why it's a more accurate prediction. Okay, and then it says, would it be preferable to describe the trend using a line that makes the differences in the actual and predicted values large or small? We want our actual values and our predicted values to be close together, right? We want them to be, pretty similar, so we don't want them to have much difference at all. We want them to have small differences. Okay, we want our line and our dots to be as close together as possible, and for most of these they are. All right, let's continue on. All right, for exercise 7 we have a new graph. This is showing the age and price of used compact cars that are advertised in a local newspaper. So based on that scatter plot, please tell me the relationship below. You have 30 seconds. All right, based on this plot, you should have noticed that this is a downward trend. Going from left to right, it is going negative, and it does form the pattern of a line. So this is a negative linear trend. All right, moving on. Here it says Nora drew a line she thought was close to as many points and found the equation of the line. She used the points 13, 6,000, and 7, 12,000 on her line to find the equation. Explain why those points made finding the equation easy. Well, we talked about this before, that they make it easy because they're whole numbers. Right? When we go to find our m value, we have to do a lot of subtraction, and we don't want them to be like, 13.85, 6,221, right? We just want them to be nice, clear, whole numbers, chunked out as much as possible so that we can calculate that easily. C says find the equation of Nora's line for predicting the price of a used car given its age. So they already gave us the 2 points we can use to find our m value, and then we just need to find our b value. So remember, m is y2, so our y2 here is 12,000 minus y1, 6,000, over x2, 7, minus x1, 13. 12,000 minus 6,000 is 6,000. And 7 take away 13, this is going to be negative, 6, 7, 8, 9, 10, 11, 12, 13, negative 6. When we simplify this, 6,000 divided by negative 6, it comes out to negative 1,000. So this is our m value. And now we just need to find our b value based on the graph. Where does this line look like it's going to start? And we don't see it because this goes, if we were to extend this line, it would go way off the graph, and we don't have a number up here. We know it's going to be above 16,000 though, but we have to calculate it. So I'm going to plug in what I know, y equals mx, negative 1,000x, plus b, and from there I'm going to solve for b, so I need to find a y and an x to plug in. Well, they give us 2 points up here, so I'm just going to use the one that's a little bit smaller, 7 and 12,000. So my y is 12,000, my x is a 7, and now I can solve for my b. So this simplifies to say 12,000 equals negative 7,000. plus b. I do the opposite of plus negative 7,000 plus positive 7,000 on both sides. I get that 19,000 equals b, which makes sense, right? This is about 19,000 up here. Well, it actually is exactly 19,000 up there where it's going to hit. So I have my b value, I have my m value. I can write my equation y equals negative 1,000 x plus 19,000. This is the equation for this line. All right, please make sure you have it down, and we will move on to the next screen. All right, on this screen, I want you to tell me that based on this line, which point on the line is the furthest from the actual prediction. So what this means is identify which point is furthest away from our line of best fit. I'll give you about 30 seconds to do that. And you should have identified that this point right here for this car that is 10 years old is furthest from our line. Which means that it is furthest from our prediction, because we would have predicted it to be all the way up here, but instead it is way below. That's an outlier. Let's continue. So now we're going to use our equation that we had come up with, y equals negative 1,000x plus 19,000, to predict what a 10-year-old car would be on our line. We're going to predict what would we figure out the price would be if we used our equation. So what you're going to do, remember our age is our x. So we're looking for a 10-year-old car, so we're changing this x to a 10. So go ahead and do that and solve this and come up with your prediction. Give you a second to do that. All right, based on that math, you should have been able to predict that a 10-year-old car, based on our graph, would be $9,000. And that's exactly what we did predict right here, right? It hits 9,000 exactly. Okay. The actual difference in our data set is pretty big, but that is because this is an outlier. I'm not even going to answer that question on there because we've talked about that already many times. Okay, so let's continue on. So when we're looking at our actual value of that car and the predicted value, the actual value was $4,000 compared to $9,000. So that's a difference of $5,000. We're $5,000 off. That's a lot, right? But we talked about it many times now. It's because this was an outlier. This point was just a random point. Something was different about this car. Maybe this car sat in a driveway and was never used. Maybe it was a special edition car. Maybe they don't make these cars anymore, right? So this is not typical of our answers in our data set. Most of our values are a lot closer to this line, you'll see. They're right off the line. The only one that's further away is this big outlier for the 10-year-old car. Okay? So I'm just going to write this as not typical. That was an outlier. Okay? Moving on. Let's close this lesson out. To summarize our lesson, a line can be used to represent the trend in a scatter plot. Evaluating the equation of a line determines a value predicted by the line. And a good line for prediction is one that goes right through the middle of the points in a scatter plot and which all of the points tend to fall close to. Okay, let's go ahead and go over our exit ticket. All right, for your exit ticket today, you're going to have to draw a line of best fit. You're going to have to find the equation for your line of best fit. And you're going to have to use your equation to find the difference between observed speeds and predicted speeds. So like that last question where we said, okay, well, we observed that the point on the line is at 4,000 but we predicted it would be at 9,000. So there was a $5,000 difference in our predictions. Okay, so you're going to have to do something like that on your X ticket. Go ahead and get into Galileo and get started on that, and then we will go over it. And if you finish before we go over it, please work on your reflection.